Welcome to another solution video, paper 22 of exam 9709 ANAS level math, Cambridge International. Question number 1 has two absolute parts on each side of an equal sign, and three things make it very easy kind of question. 1, there's an equal sign. 2, there are complete absolute on both sides. And 3, there is no power, there's simply linear functions inside each absolute sign. Okay, so in such case, there could be four possibilities. Let's list all those four conditions. Left side positive equal to right side is also positive. Left side is positive, right side is negative. Left side is negative, right side is positive, and then we have both of them negative. Why? Because we don't know what is inside. Absolute will make it positive, but what is inside, we're not sure. So these are the four possibilities. But we can see that these two are exactly same situation. That's why I said it's a good part that both of them are completely absolute. So we can cancel out these two negatives and we get the same thing again. Here also, if we switch each other, it does not affect the equation. So basically, if I focus on only the first two, that's enough. No need to go for the two because they are exactly same situation. So let's do the first situation, both positive. So 5x minus 2 equal to 4x plus 9, no change in anything. Okay. Second situation, let's take that this inside is positive. So 5x minus 2 is positive, but 4x plus 9. So let's solve this left side first. 5x minus 4x equal to 9 plus 2. So x is 11. What about this? 5x minus 2 equal to minus 4x minus 9. So let's bring minus 4x to the left side. So 5x plus 4x equal to negative 9 plus 2. So 9x equal to negative 7. X is equal to negative 7 over 9. These are the two answers. No need to check them because this is equal. In inequality, we check, we make sure that we are right. But here they are exactly correct answer. If you want to check, you can just put 11 in place of x and see that they are equal. Put this in place of x, you will see that they are equal. Let's go to question number 2. A curve has equation y equal to 7 plus 4 ln 2x plus 5. Find the equation of the tangent. Equation of the tangent, all right, to the curve at this point, giving your answer in the form of y equal to mx plus c. So let's write y equal to mx plus c. We need m first. M is gradient of the line, and line in this case is tangent. So gradient of tangent is nothing but dy over dx. So let's put differentiate this one and we'll get dy over dx. So dy over dx, the differentiation of 7 is 0, no need to write it. Next one is 4. The differentiation of ln 2x plus 5 will be 1 over 2x plus 5 multiplied by differentiation of the inside of ln, which is 2x plus 5. Differentiation of that will be just 2. So we get 8 over 2x plus 5. This is dy over dx. But m at x equal to, because our dy over dx came in terms of x. So look at x. What is x? Minus 2 in the point they have given. So m at x equal to minus 2 will be what? 8 divided by 2 times minus 2 plus 5, which is 8 minus 4 plus 5 is 1. 8 divided by 1 is 8. This is the gradient. So here we got m. Y equal to 8x plus c. Now only thing is that we have to find c. And this point minus 2, 7 lies on the tangent, right? Because if this is the curve, this is the tangent, and the point where this tangent is minus 2, 7. So this point lies on the tangent. This is the equation of tangent. That means this point coordinates will satisfy the equation, and we'll plug it in there and we'll get C. Y is 7 at that point. 8 times minus 2 plus C. And 7 equal to minus 16 plus C, and 16 comes here, plus 7 will be 23 equal to C. So finally our equation becomes y equal to 8x plus 23. This is in the format of y equal to mx plus c. Moving on, question number 3. The variable x and y satisfy this equation, alright, where a is a constant. The graph of ln y against x. So let's visualize this. This is ln y against x. Gives a straight line with gradient 0.239. 0.239 will be very, very shallow, kind of very low gradient. 0.239. This is the one. Find the value of a correct to 3 significant figures. So since this is our x-axis and this is our ln y-axis, not y-axis, that means our equation y equal to mx plus c, which is the equation of a line, should be in terms of ln y and x, not y and x. So it should be ln y plus mx plus c. This should be our format, right? And this m they have given gradient as 0.239. So what will we do? This equation that they have given us, we will try to convert it into this format. Y equal to 3 to the power 2a multiplied by a to the power x. Now we have to convert y to ln y, and that should also cause x to become a normal mean number. Okay, so let's do it. Let's apply ln to this side and ln to this side as well. All right, so now it becomes ln y equal to, now there are two parts inside a ln which are multiplying. If I want to separate them, I can apply ln to each one of them, but they will add. That is the law of logarithm. Whenever the contents of a ln which are multiplying separated with ln with each other, they add as a ln. So this becomes our new format, but still nowhere near to this one. So let's bring these exponents to the front and they will become the coefficient, and then we will be closer. Ln y is equal to 2a ln 3 plus x also comes here and ln a. Let me rearrange this to match with our required format. So ln y equal to, let's write the x part first, this one. That too ln a first. Ln a times x, and a and x are not multiplying, ln a and x are multiplying, plus 2a ln 3. Now compare with this equation. Ln y is ln y, very good. X is x, very good. That means ln a is m gradient, which is 0.239. Okay, and this is c. Y equal to mx plus c, right? Why c? Because it's a constant. So now let's find the value of a from here. Ln a equal to 0.239. This is what we've got. Now we will remove a ln from here. When we remove ln from one side, and the other side becomes the exponent of e, which is the base of log. Okay? This is natural log base e, and because ln has been removed from the left side, the other side becomes e to the power 0.239. They asked us what is the value of a. The value of a is e to the power 0.239, which comes out to be 1.2699, rounded off to 3 significant figures, 1.27. Let's see, this has one more part, b. Hence, find the value of x when y is 36, correct to 3 significant figures again. So in this equation we will put 36 in place of y because they said y is 36. Ln a we know now, ln, and it is e to the power 0.239. I did not write 1.27 because natural log and e will cancel out, and that's why we will be easy. It will be easier for us. X we want to find out, then 2 times, here we can write the value of this 1.27 because there is no natural log before this. So then we have ln 3. Okay. So this is a whole thing is constant. Let's bring it to the left side with this one. So it becomes ln 36 minus 2 times 1.27 is 2.54 ln 3 equal to, I said they neutralize each other, just 0.239, and then we have x. Alright, so now divide both sides by 0.239 and 0.239. Here they cancel out. We get the value of x by putting this very carefully in a calculator, and you'll get your value. Let me do it myself. By the time I do this, I would request you to subscribe to my channel. I think I'm the first person in the world to solve this particular exam paper. And you like the video, share with your friends, let them also know that this solution is out, and I'm motivated to make even more videos for you in future. Thank you. So when I use my calculator, I got 3.318, but they said correct to 3 significant figures, so we can write 3.32. That is the value of x when y is 36. Here is the next question, number 4. Show that this trigonometric expression is equal to 1. Okay, so we will need double angle identities for sine and cos. But cos has 3 options. Let's see which one works. First, we'll do this one. And cot. Sine 2 theta. Let's focus on the left hand side. Sine 2 theta is 2 sine theta cos theta. And then cot theta will be cos theta over sine theta minus, I will leave it for some time because I want to know which one will be useful here. Sine and sine cancel. I get 2 cos times cos, cos square. Okay, so I need cos square theta. The identity which I will use here will be cos 2a equal to 2 cos square a minus 1. This is the identity I will use. So in place of cos 2 theta, I will write 2 cos square theta minus 1. Okay, because I had cos square here, I wanted to cancel that one. So let's open that bracket now. 2 cos square theta plus 1. This negative and this negative, make it positive. These two cancel out. And voila, we left with only one, which is right hand side. This is what they wanted us to show. Here we have the b part also. Hence, find the exact value of this. Can you see here? This is sine 2 theta. This is cot theta. Here we have sine double of this because 1 over 12 pi times 2 is 1 over 6 pi, right? Because 2 and 12 cancel out. So it is exactly same format, this one. So let me write this one first. Sine 2 theta cot theta minus cos 2 theta equal to 1. This is what we just proved, right? So because they are asking just sine and cos, can you see? Sine and cot rather. The sine and cot will remain here. So it will become sine 2 theta cot theta equal to 1 plus cos 2 theta, right? That means in place of this, can I write the question now? It becomes sine 1 over 6 pi cot 1 over 12 pi. This is your question. But now this one is equal to this. So this question becomes 1 plus cos 2 theta, and 2 theta is 1 over 6 pi, isn't it? This is 2 theta, 1 over 6 pi. We just got it here. So this is what we have to evaluate now. So it becomes 1 over cos 1 over 6 pi is square root 3 over 2. And they're saying find the exact value, and I think this is the final exact value. There is one C part also. Find the smallest positive value of theta in radians satisfying the equation. Isn't it the same equation, that identity for every equation? Oh yeah. The difference is that here it is sine 2 theta cot theta minus cos 2 theta equal to 1, right? But here it is not cos 2 theta, it is 3 cos 2 theta. So that means it is not identity anymore, it will change, and they are asking us to find the smallest positive value of theta. Because in any identity, any angle will work. So there is no smallest, no greatest, every angle will work. Since this is not identity anymore, so we have to solve it. So we, in the previous part, we found that this was equal to 1 plus cos 2 theta, as far as I remember. 1 plus cos 2 theta, yeah, this is what we got last time. Okay, minus 3 cos 2 theta is there, is equal to 1. So let's simplify these two. It will become minus 2 cos 2 theta, because both of them are cos 2 theta now. And this one minus 1 will be 0, because 1 goes there, becomes minus 1. 1 minus 1 is 0. And if we divide by minus 2 both sides, again it will be 0. So basically it is cos 2 theta equal to 0. 2 theta is cos inverse 0. Now this is smallest possible. Now you can use a calculator or just use the graph. For 0, 1 and minus 1, I recommend that you use graph. So the graph of cos looks like this, because we want cos. This is the cos graph. So where is it 0? The smallest possible. This angle is pi by 2, right? So that's what we will write, the smallest value. 2 theta equal to pi by 2. And 2 we can divide by 2 or multiply this, cross multiply here. So final answer is theta is pi by 4. This is smallest angle. For this equation is true. Next one. Given that tan square x equal to y, again a trigonometric equation, but the things show that its differentiation is this. So y equal to tan square x. We want to find differentiation of this. So whenever this tan square x can also be written as tan x to the power 2, is the same thing. Okay, so whenever a function is squared, to differentiate, this 2 comes in front. So 2 comes here and the exponent goes down by 1. It is 2 minus 1. And further, we multiply by the differentiation of what was inside the bracket that had that exponent. 10x had the exponent, right? So we'll differentiate 10x also. Differentiation of 10x is secant square x. So 2 10x and secant square will be 1 plus tan square x. The secant square x is 1 plus tan square x. That's the identity. You get this identity in your exam. So now multiply 2 tan x times 1 is 2 tan x. 2 tan x times tan square x will be plus 2 tan cube x, which is right hand side of this particular equation. So proved. B part. Find the exact value of this definite integral. They should have used the word hence here. Why? Because look, it is 2 tan x plus 2 tan cube x. If I take 2 common, what do I'm left with? Tan x plus tan cube x, right? This is what I'm left with, and tan x and tan cube x is here already. So we can use the part A for part B. Let me do that. Okay. So I will separate these two and I will write tan square separate. So from 1 over 4 pi till 1 over 3 pi tan x plus tan cube x dx, and let me put a 2 here and 1 over 2 outside, right? So that half times 2 is 1. I have not made any changes to this. Only change I made that I've separated tan square x outside. So that doesn't make any difference. That's good. Again, 1 over 4 pi till 1 over 3 pi. Now, if this is the differentiation of the question, previous question in part A, look, this one. That means the integration of this will be the original question. So basically, if I integrate this one, I will get especially tan square x. That's it. And half was in front. This half, I can write half. That fast. There's no need to do anything. Take help of the A part. Now, the problem is with second part. So that is not also difficult. Tan square x. I can write that one as secant square x minus x. Sorry, not minus x, minus 1. That's the identity. Tan square x is equal to secant square x minus x dx, and integrating it will be very easy. So our first part was half tan square x. I'm integrating this and I'm not writing the closing one. Integration of secant square is tan x. Integration of minus 1 will be minus x plus c, done. In 3 steps we did with the help of part A, and now we'll evaluate this because they're saying find the exact value. So the exact value, we'll substitute 1 over 3 pi first. So half tan square 1 over 3 pi plus tan 1 over 3 pi minus 1 over 3 pi plus c. This is when I substitute 1 over 3 pi. Let's do the same with half tan square 1 over 4 pi plus tan 1 over 4 pi minus 1 over 4 pi plus c. First thing we should do, cancel out c, and now we'll evaluate. Half tan square 1 over 3 pi, tan 1 over 3 pi will be square root 3. So square root 3 square. Because of this square, then we have tan 1 over 3 pi, which is square root 3, minus 1 over 3 pi minus half tan 1 over 4 pi is 1. You can use your calculator. I know the values, that's why I'm saying this, but you can use your calculator. Plus tan 1 over 4 pi 1 again, minus 1 over 4 pi, and not minus, it will plus, and this will be minus. Because of this minus, we should apply this to all 3 of them. Done. And now let's simplify this. 3 square root and square cancel, so it will be 3 over 2. Then plus square root 3 minus 1 over 3 pi minus half plus 1, sorry, not plus 1, minus 1, plus 1 over 4 pi. 3 over 2 minus half is 1, and minus 1 will be 0. So that means these 3 cancel out. What are we left with? Square root 3 here. And the LCM will be 12. And 4 minus 1 will be minus 1 over 12 pi. 1 over 3 pi minus 1 over 3 pi plus 1 over 4 pi is minus 1 over 12 pi. This is the final answer. Question 6. The polynomial px is given by this. Find the quotient when it is divided by this, and remainder, show that remainder is this. Straightforward. So let's do the long division and we'll get it. Let's see, 4x cube plus 16x square plus 9x minus 15. Quotient will come here. 2x, what should I multiply with 2x so that I get 4x cube? I'll need 2x square. So 2x times 2x square will be 4x cube. 3 times 2x square, it has to multiply with 3 as well, will be 6x square. Now we subtract minus minus. 16 minus 6 is 10x square plus 9x minus 15 from there without changing sign. Okay. Now 2x to be multiplied with the 5x to get 10x square. Then 3 multiplied with 5x gives us 15x. Alright, positive, positive. Subtract, this cancels out. Minus 6x minus 15. Now 2x should be multiplied by minus 3 to get minus 6x. So minus 6x, and that will be minus 9. Yeah, 3 times minus 3, minus 9. This becomes positive, this becomes positive, they cancel out. Minus 15 plus 9 is minus 6. Yes, the remainder is minus 6. Let me show here. This is remainder which they wanted us to show, minus 6. And this is quotient which they asked us to find out. Here is the B part. So find the integration of px, which is this, divided by 2x plus 3, this. Alright. So px divided by 2x plus 3 can be written as, okay, the full quotient first, 2x squared. So this basically will become 2x squared plus 5x minus 3 dx, this complete one. But then we have a remainder of minus 6. So we'll have minus 6 over 2x plus 3, right? So the remainder becomes the part of the fraction, and the one which was quotient becomes a complete expression. So we can integrate this one first. It will be 2x cube over 3 plus 5x square over 2 minus 3x. This is the integration of these. And here we have a denominator which is linear. And the best part of the linear is that it becomes, when we integrate, a natural log. 2x plus 3. Now minus 6 will remain minus 6. And we have to divide further by the differentiation, not integration, differentiation of this whole thing. Differentiation of 2x plus 3 is 2. So we have to divide this expression by 2 plus c. This is the integration. Let's try to simplify. Only this can be simplified, right? Everything else remains. Nothing is getting cancelled out. 2 over 3 x cube plus 5 over 2 x squared minus 3x minus 3 over 2 ln 2x plus 3 plus c. That's the integration. What's next? Factorize px plus 6 completely and hence solve the equation. So I need px first. So this is the px which I'll copy. Here it is. This is px. So we are going to add 6 to this, px plus 6, and we have to factorize this. Okay. So what does this become? 4x cubed plus 16x squared plus 9x minus 9. Yeah. So now because they have removed the remainder, we get a perfectly factored polynomial from this. So we'll factor this. But the problem is where to start. We don't know what are the factors of this. So what do? We look at the last digit, minus 9. Factor minus 9. What are the factors of minus 9? Plus minus 1, plus minus 3, and plus minus 9. substitute them one by one into this and you will get it. Let's see this one first. P1 plus 3. Okay, because it is plus 3, no, plus 6. And we will try to find if it gives us 0 remainder. So 4 1 cube plus 16 1 square plus 9 times 1 minus 9. It becomes 4 plus 16 plus 9 minus 9. No, it will not give you 0. These cancel, but we get 20. So we'll have to go minus 1. So 36, yes, this is working. So minus 3 is one of the factors of this particular one. So let's write x plus 3. If minus 3 is a root or 0, we make it a factor by changing the sign of the 3, x plus 3. The logic is, we know x equal to minus 3 is the root. So minus 3 comes here, it becomes x plus 3 equal to 0, and that's why this becomes factor which will make the whole of this 0. So x plus 3 divides 4x cube plus 16x square plus 9x minus 9, and definitely we'll get a remainder, and definitely we'll get a remainder of 0 in this case. Okay, so x plus 3 4x square 4x cube, long division again, okay, plus 4x square times 3 12x square, 4x square plus 9x minus 9 plus 4x square plus 12x. So this becomes a minus 3x minus 9 minus 3. See, we got a remainder of 0 because they are exactly same, they cancel out. So this is the second factor. One factor was x plus 3, second is this one. So we are left with x plus 3 first factor, 4x square plus 4x minus 3 second factor. And they are saying factor completely, right? Completely. That means we have to factor the quadratic part also now, this one. So let's focus on that one only. Okay, I'm doing my usual factoring method. You can use your calculators, or quadratic formula is a good idea, but you should know how to convert roots into factors. Okay, but I'm doing factoring method. 4 times minus 3 is minus 12, and minus 6 times 2 is also 12. So okay, 4x square minus, no, plus 6x minus 2x minus 3. 2x taken common here, 2x plus 3 minus 1, 2x plus 3. So I got the other factors also. 2x plus 3 is in both, 2x minus 1. So finally, what do we get? The factors are x plus 3 was already a factor. Now we got two more factors, 2x plus 3, 2x minus 1. This is the factoring. They're also asking, hence, solve the equation. P cosec 2 theta plus 6 equal to 0. That means each x will be replaced by cosec 2 theta. Yeah, 2 theta. So this x becomes cosec 2 theta plus 3, 2 cosec 2 theta plus 3, 2 cosec 2 theta minus 1 equal to 0. Now, we already have factored part, so it becomes easy. Cosecant 2 theta plus 3 equal to 0. This is our first equation which will give us some solution. Let's write the second one also. We had 2 cosecant 2 theta, right? Yeah. 2 cosecant 2 theta plus 1 equal to 0. Third one, 2 cosecant minus 1 equal to 0. So this becomes cosecant 2 theta equal to minus 3. 2 cosecant theta plus 3, this is 3, plus 3 equal to 0, so it will equal to minus 3. So cosecant 2 theta equal to minus 3 over 2. By same method, cosecant 2 theta equal to half. These are three equations and we have to find the value of theta, and theta range is given in domain 0 to 135. Any answer beyond 0 to 135 is unacceptable. Okay, let's focus on the first one. Cosecant 2 theta is not in our calculator, so we will reciprocate. We'll reciprocate this, it becomes sine 2 theta if I reciprocate cosecant. So we can't reciprocate only one side, I have to reciprocate the other side also, minus 1 over 3. So 2 theta becomes sine inverse minus. So sine is negative in these two quadrants, and this will be sine inverse positive 1/3, because we can't use this or this where sine is positive. So we will just write sine inverse 1/3 without negative, because negative has already given us quadrants. So let's find this acute angle by sine inverse 1 over 3 in my calculator. By the time I do this, I request you to subscribe to my channel, like this video, share with your friends, and motivate me to make many more videos like this. Alright, sine inverse 1 over 3 comes out to be 19.47. So that means this angle is 19.47. So what does our angle become? Because there are two more options possible. So 2 theta 1 is 180 plus 19.47, because it is in third quadrant. We start from 0, this is 180 and 19.47 more. So 2 theta 1, 199.47. To find theta 1, first answer, 199.47 divided by 2, which is 99.735. So let's stop here, 7 degrees. This is the first answer. Let's move on to the second option. Second option was cosecant 2 theta equal to minus 3 over 2. So sine 2 theta is the reciprocal of cosecant 2 theta equal to minus 2 over 3. You have to reciprocate this also. And same way, because it's negative, we'll get an answer here and here. I did not take the fourth because they said less than 135. And if I take this angle, which is just 19.47, it will not give me the 135. I'm sure about this. That's why I did not take this one. Okay. Here also I will not take this one. So it will be how much? Sine inverse 2 theta 2 equal to sine inverse 2/3 positive. We already know the quadrant. We have to find this angle. Okay. Let me use my calculator again. It comes out to be 2 theta 2 equal to, it is in again third quadrant, 180 plus, and sine inverse 2/3 is 41.81. So theta 2 equal to 221.81. Okay, so theta 2 will be 221.81 divided by 2, and finally second answer comes out to be 110.9. And if they want 3 significant figures, we can write 111. Yeah, degrees. Let's see if they said something specific. No. So we can write our answer like this. Let's move on to the third one. Third one was cosecant 2 theta equal to half. So sine 2 theta, again the reciprocal will be equal to reciprocal of this, which is 2. And sine can never be more than 1 or less than minus 1. That means this answer is inadmissible. This will not give us any solution. So we have just two solutions, which are 99.7 and 111. A curve has this equation, show that its differentiation is this. So let's differentiate, and since there is a combination of x and y, they are multiplying, we will need to use implicit differentiation. Alright, so e to the power 2xy minus e to the power y equal to 100. Whenever y will be differentiated, we will add a suffix dy over dx, right? So these two are multiplying, we'll use product rule here. So product rule says differentiate the first one but keep the second one same, plus keep the first one same but differentiate the second one. This is straight away e to the power y. Differentiate this alone, okay? And differentiation of 100 is 0. Don't keep it inside this. Now, differentiation of e to the power 2x will be 2 e to the power 2x, and we have y untouched, plus e to the power 2x, differentiation of y will be 1, but because it's y, we will write dy over dx, minus e to the power y will be differentiated just like e to the power x, so it is copied and nothing else, but because it was y, dy over dx equal to 0. So this will come to the right side. Let's make it minus 2 e to the power 2xy. It became negative when it went to right. Now these two have dy over dx. We can take dy over dx common from both. What is left here? E to the power 2x. Let me write it properly. Okay, and what is left here? Minus e to the power y. And now, to isolate dy over dx, I will divide this by e to the power 2x minus e to the power y. Here also e to the power 2x minus e to the power y. These cancelled out. Dy over dx will be this. But it is not matching with our answer, right? Look, there's a negative here, there's no negative here. And these two are opposite sign here. So what we can do, we can multiply this by minus 1 and multiply down also by minus 1, and we'll get the what we want. So this minus and this negative 1 will make it positive. That is the requirement. And this will become positive, so I will write this one first. This one will become negative, I'll write this later, and this is what they wanted us to show. Okay, next part. Show that the curve has no stationary point. Stationary point is decided by the gradient equal to 0, because this is turning point, which is called stationary point. These two are turning points, and here the gradient is 0 because the tangent is a horizontal line. This is the gradient of the tangent, so we'll make this equal to 0 and see how many solutions we get. Since they're saying show that curve has no stationary point, we should not get any solution. So 2 e to the power 2x times y divided by e to the power y minus e to the power 2x equal to 0. The denominator, it goes and cross multiplies with 0 and vanishes. We are left with only 2 e to the power 2x times y equal to 0. There are two parts multiplying which are equal to 0. That means either 2 e to the power 2x is equal to 0 or y is equal to 0, right? Because they are multiplying. Let's divide both of them by 2 first, and we get e to the power 2x equal to 0. E to the power 2x can never be 0 because e is a constant, it's a positive constant. No matter what exponent we give to this one, we will never get any solution for this. So this answer is invalid. What about y equal to 0? For this, let's go to our main equation, which is this one. E to the power 2x y minus e to the power y equal to 100. Okay. e to the power 2x times y minus e to the power y equal to 100. So let's see if y equal to 0 is valid or not. So y equal to 0 we'll put here, this y will put 0, e to the power 2x times 0 minus e to the power 0 equal to 100. This 0 will make this whole thing 0, so minus e to the power 0 is 1 equal to 100, which is not true, right? So that means both the solutions which we are getting by equating dy over dx equal to 0 are invalid. So we'll say that there is no stationary point. However, it is required to find the x-coordinate of P, the point on the curve at which the tangent is parallel to y-axis. Parallel to y-axis. Let's see. This is x-axis. This is y-axis. That means tangent is parallel to y-axis. That means it is curve is something like this, which is not actually a function, right? But they're saying that what is the gradient of this vertical line? dy over dx is undefined, right? A vertical line, the gradient of vertical line, which is the gradient of the tangent, is undefined. That's what they're saying. So dy over dx, what was that? Let me go back to dy over dx. It was e to the power 2xy ey minus e to the power 2xy over e to the power y minus e to the power 2x. This was dy over dx, right? It is undefined. How can this become undefined? It will become undefined if denominator is 0, isn't it? 3 divided by 0 is undefined, 5 divided by 0 is undefined, pi divided by 0, anything divided by 0 is undefined. That means e to the power y minus e to the power 2x is equal to 0. E to the power y is equal to e to the power 2x. Both are e's, so we can ignore, we can equate the exponents, and this is the equation we got. Now, what is the question? Show that x coordinate of P satisfies the equation this one. All right. So x coordinate of P. So y equal to 2x, and our main equation was this one, isn't it? So let's put it there. E to the power x to y minus e to the power equal to 100. E to the power 2x y minus e to the power y equal to 100. So y is equal to 2x. This is 2x. So 2x e to the power 2x minus e to the power 2x equal to 100, right? I replaced y by 2x. Let's take e to the power 2x common from the 2 because both of them have this, and we are left with 2x minus 1 equal to 100. Okay. We have to isolate one of the x's because there is a ln in what we want, right? We want this one. Okay. So e to the power 2x stays here, and this 2x minus 1 goes and becomes denominator by cross multiplication. 100 divided by 2x minus 1. Now to remove this e, we will have here 2x equal to ln 100 over 2x minus 1. Yeah, since they are dividing inside ln, just like in one of the previous questions we did, we'll separate them by applying ln to both of them. So 100 minus ln 2x minus 1. Divide this by 2, divide this by 2, divide this by 2. So x is equal to half ln 100 minus, let's make this, do they want positive or negative? They want negative is okay. They want to leave it like this. Half ln 2x minus 1. Is it matching? Not yet. So we have to get rid of this half. X equal to ln 100 to the power half minus half ln 2x minus 1. So x equal to square root of 100 is 10. Ln 10 minus half ln 2x minus 1, exactly what they wanted us to show. Final part of the final question. Use an iterative formula based on the equation part C that we got here. Okay. P correct to 3 significant figures. Great. Use initial value of 2 and each iteration of 5 significant figures. Okay. So the first, the iterative formula that we will get from here will be xn plus 1. This side becomes xn plus 1. The other one remains log, not log, ln. 10 minus half ln 2xn. The initial number will be here, x1. So they're saying use x1 equal to 2. So we'll put this xn as 2. So this will become x2 equal to ln 10 minus half ln 2 times 2 minus 1. Okay, so this is x1 for us. This became x2. All right. If I use my calculator, I get this equal to 1.7533. They said 5 significant figures we have to write. So these are the 5 significant figures. 1, 2, 3, 4, 5. Okay. Now we'll go to x3. For x3, x2 becomes xn. So half ln 2 times now 1.7533 minus 1. And this gives us 1.8. I'm rounding off because they are saying that we have to write 5 significant figures. That's why I'm writing. There are more digits after this, but I'm rounding them off. So they are not equal yet, 3 significant figures. So I'll continue. Ln 10 minus half ln 2 times 1.8431 minus 1. What I get here is 1.8085. Okay, let's move on. Still not there. x5 is ln 10 minus half ln 2 times 1.8085 minus 1. 1.8216. x6 equal to ln and here we stop because 3 significant figures, if I round them off, and 3 significant figures here, if I round off, it will be also 1.82. So the final answer is 1.82, 3 significant figures.